Hi everybody, I'm Catherine Rundell.
I'm Brennan O'Ryan.
I'm Jasmine Gideon.
And I'm Kayla Epler.
And for our field day, we did the Stroop effect experiment. I need 2 volunteers. It's only going to take like a couple seconds. So, anybody? And then another person?
You're here.
Okay. I need one of you to step out in the hall really quick. Then you can come up here and go ahead and stand back here. And what I'm going to have you do is flip the paper over and read the words. And I'm going to time you. Whenever you're ready. You go.
Red, blue, white, yellow, brown, purple, black, green, orange.
Okay. Like 5.3 since you didn't start on Okay. Now, that's with the his pause taken out. It was like 9 seconds with the pause. Okay. So now I'm gonna have you flip it over and say the color that each word is.
Okay.
You gotta go.
Yellow, purple, black, green, red, orange, white, brown, and blue.
7.2. So you're 2 seconds slower. Thank you. You can have a seat and then sheet. You can come up here. Okay. I'm gonna have you flip the paper over and read the words
Out loud.
out loud.
Okay. In which order? Okay, red, blue, white, yellow, brown, purple, black, green, orange.
Okay, like 2.5 seconds. Now, I'm gonna have you flip it over again and say the colors of the words that each one's printed in. Yeah.
Yellow, purple, black, green, red, orange, white, brown, blue.
9.7 seconds. So 7 seconds slower. You can have a seat. Thank you. So that's what the Stroop experiment was. That's what we did. Our hypothesis was that if a reader is reading a list of words and they say just the word, it'll be faster than if they say the actual color of the word. So for our experiment, we chose to have 9 words, and this is the paper that they were shown. And each word was a different color. So we tried not to have them, because most people read left to right, we try not to have like this word be a red or this one be a blue. We tried not to have that next to each other. And we did what we just did where we had them flip it over and time it, and we tried not to make sure they knew what was going on. Sometimes people flipped it over and were like, oh, this is what we're doing. So we ran into that issue where people kind of knew what was going on and whatnot. And we chose 9 words because it was fairly short and quick, so if I asked someone to kind of do an experiment with you really quick, it wasn't taking up half their day.
We had 40 subjects overall. Each one of us took 10, and we split into 2 groups. Half of us did the words and half of us did the colors. And the way we collected the data was we took their age or grade level, the time it took them to complete it, and the number of mistakes they committed. And our results were that it would take much longer to read the color than the word, and each person that read the color had a 20% chance of actually committing a mistake, and no one made a mistake reading the words, which is probably a good thing. And they took significantly longer, almost 3 seconds longer to read the color than the words. And age and gender didn't really seem to have much of an effect on the experiment. And these findings do corroborate Stroop's original findings, which we will get into later. This is a graph of the times it took for each group to do the experiment. So.
Okay, the Stroop effect, it started in 1935 from John Ridley Stroop, and he compared reading a list of words printed in black with reading the same list of words printed in incongruent colors. And there was very little difference in the 2 lists. And the second one, he compared the naming of colors for a list of solid colored squares with the naming of colors for a list of words printed in incongruent colors. And that took 74% longer than it did the first time. The reason why is because your brain reads words much faster than it does colors, and it's pretty much like a race trying to see who gets there first, and usually the words always get there faster. If your task is to identify the color, the hesitation comes from that information trying to push through, so the word itself always gets in the way of the color. Our original findings, semantic interference is the naming the ink color of neutral stimuli, which is the black ink, is faster than incongruent conditions. The semantic facilitation is if the word matches the color, can be identified faster than if the color and the word don't match. And the Stroop asynchrony is both of the previous findings are invalid if you have to read the word instead of identifying the color.
Okay, so the Stroop test is used to investigate a person's psychological abilities. The things that it measures are selective attention, cognitive flexibility, and processing speed. It even helps diagnose some mental illnesses like schizophrenia, dementia, and ADHD. It looks at parts of the brain involved in planning and decision-making and managing real-world interference. So it looks at the complications between texting and driving and doing multiple things at one time. Multitasking, that's what it's for. So the theories behind this are the speed of processing theory, which is the thought that the two different processes take different times, have different speeds. So the words are faster. It's faster to read the words than it is to identify the colors. The selective attention theory, your brain needs more attention to identify colors than it does to read words. That's why it would take longer. The automation of reading theory or automaticity hypothesis. Reading is automatic. Obviously, it doesn't take a lot of brain power to read a book once you learn how to read. Identifying colors is not. So your brain doesn't need a lot of attention to read, but it needs just enough attention that it'll block the attention for identifying colors. The parallel distributed processing theory, the strength of the pathway is more important than the speed of the pathway, so the reading pathway is stronger than the color identifying pathway. Yeah, those are references. I don't know anything about the article you gave us, but...
That's okay. Good job.